Hi, my name is Kevin Ward
And I'm Josh Mulligan.
with Tricky Fast Studios. In this part of creating a third-person shooter with Cat Game Builder, we are developing the Soldier AI. So, first things first, go into Tricky Fast, Examples, TPS, that is TPS for third-person shooter, and find the folder called Starting Prefabs. Here, you should see a variety of prefabs that may or may not already be in your scene. In particular, we are looking for the Soldier prefab. You may also see the Drone, which is another AI we will cover later in the series. But for now, grab the Soldier from your project window and drag him into the scene. You'll notice on the character that it's basically an empty game object with a character model attached to it, and a few components and scripts as well as a canvas for its health bar. If you are watching this while using your own AI, you'll need to augment your style to this format for the tutorial. We start with an empty game object as the base, attaching components and other objects to our AI as we need more complex behavior. Now that we have our soldier, we need to check if our nav mesh is set up. Nav mesh, or navigation mesh, is a data structure which describes the walkable surfaces of the game world and allows game objects with the nav mesh agent component attached to it to find paths from one walkable location to another in the game world. This mesh, as we call it, is built, or baked, if you will, automatically from your level geometry. You can read more about this topic in Unity's manual under Navigation and Pathfinding. For our purposes, we just need to check our scene objects and the state of our nav mesh. This is handled by Unity's navigation window, which can be accessed through going to the top bar, hitting Window, then Navigation. By default, the nav mesh should be baked for this level. In the case that this is not true, we just need to move to the Bake tab and hit Bake on the bottom right of the window. Adding or removing geometry from the level will make our nav mesh inaccurate to the play area. Adding more geometry is easy, and so is incorporating it into the nav mesh. Dragging a new object into the scene, you can then go to the navigation window and go to the Object tab. Inside this tab, with an object selected that has a mesh renderer component attached, you will see a drop-down labeled Navigation Area, and it's here that you will select what type of static object this is. For our purposes, we are only using walkable and not walkable. All walls should be marked as not walkable, all floors as walkable. After doing so, to confirm this, you go back to the Bake tab and hit Bake. This will recalculate the nav mesh for the whole scene and for all objects properly marked. Okay, so we want to start by going to the state machine script attached on the soldier object. Hitting the small cog symbol on the state machine script, we want to add a new state. Rename this state to Initialize Stats. And then duplicate it and rename that state to Patrol Area. Next, duplicate Patrol Area and rename the duplicate to Take Cover. Then duplicate that and rename it to Ask for Cover. Now, duplicate Ask for Cover and rename it to Add Back Cover. Next, duplicate Add Back Cover and rename it to Stand and Fight. Then, duplicate that and rename it to Attack from Cover. Next, duplicate Attack from Cover and rename it to Charge. Then finally, duplicate that, rename it to Death. In the end, we have all the states we need for our soldier. Initialize Stats. This state is the setup for other states and is where values are reset in certain cases in terms of the logic of the soldier's AI. To help set up the patrol area, we're going to need a few values within our value holder to get the ball rolling. So, go down to your value holder and click the arrow icon on the right. We need to add a Boolean value, and we shall name it has waypoints. This bool should be set to false. Next, we need to add an integer value and name it waypoint ID. Then, add a game object value list and name it waypoints. So now that we have these crucial values, we can find our waypoints. To do this, we need to add a bool value condition. Okay, so we first want to set the negate option to true. Second, for the target value, we want to select owner. Then, for the reference name, we want to provide our aforementioned Boolean has waypoints. This way, the whole chain of actions will not re-execute upon returning to this state. Now, we need to add an action list. Inside of this action list, we want to add first a set random int action, then an integer value condition. We will be using this format for the rest of this section, as it provides modularity in terms of what you may want to accomplish on your own. If you look at the set random int action, we first need to set the target value to owner, and then set the reference name to waypoint ID. Then we set the min value to 0 and the max value to 3. This way, each soldier will pick one of the 4 different waypoint paths within this tutorial. A brief note on NPC paths. Inside of this tutorial, we are using an object called NPC paths to help set up the patrol paths for our NPCs. You can go to your hierarchy and find the object called NPC paths. Its children, paths A to F, act as object references to the different waypoints which they contain. Each individual path has a value holder script attached to them with a single GameObjectValueList component attached. Each path is different. Path A has 7. Path B has 8. In theory, you could have as many different waypoints on a single path as you want. Since we're using waypoint ID as a way to select for the soldier which path to follow, you could even have 2,147,483,647 different waypoint paths. In theory, of course. Back to setting up patrol area. Anyway, you could use as many different series of waypoint paths for your tutorial scene as you like. Here, we accommodate only for 4. In the first integer value condition, we set the target value to owner, and then set the reference name to waypoint ID. We then want to set the comparison type to equal. Next, we want to set the comparison value to 0. This will control for selecting the first waypoint path, path A. Now that we have our conditions values, we need to add 2 action lists for the true and false cases of this condition. Having added those action lists, we need to set the second list to false by clicking the else action icon on the top right. Now that this is done, we can look at adding cats where we need them. Inside of the true action list, we need to add an add target to game object list value action, and then a set bool action. Inside of the add target to game object list value action, set the target value to named. We need to specify the value NPC paths. Then we want to go into the options of this target value and check off the path option and also the reference name option. In path, specify path A as the value. Then, in the reference name, specify waypoints. Lastly, we need to store the targeted list of waypoints and put them in a localized list of their own, which we can do by selecting the target of the value list field as owner, and then providing for its reference name waypoints. Now that the soldier knows where to go for its patrol area state, we need to section off this set of conditions so we do not pick a new set of waypoints upon returning to this state. So, in the set bool value action, set the target value to owner and specify for the reference name as has waypoints. Don't forget to also set the new value to true. Okay, so now on to the false action list. Now, the false action list is actually identical to the whole conditional action and the true action list we have just set up. So, we can copy the integer value condition and paste it into the false action list. The changes we will make to this is to change the comparison value to 1 in the integer value condition. Then, inside of the true action list of this second conditional action list, specify path B rather than path A. That's all. Then we can repeat this for path C and D, specifying 2 and 3 respectively for the comparison value of the integer value condition, and so on. You can add as many subsequent integer value conditions and NPC paths to make as many different variations of this as you want. Finishing up initialize stats. With this out of the way, we can add the rest of the actions for setting up the soldier. To do this, we will need to add a set integer value action, another set integer value action, a modify float value action, a set float value action, and then a change state action. For the first set integer value action, we are going to need to create a new int value called enemy health on our value holder. This will be the value which we monitor as the health value over the entirety of the soldier's life, and also what we check against when the player shoots the soldier and for when the soldier has reached certain points in its life cycle. To implement this value, we need to go back to set integer value action and set the target value to owner, and then set the reference name to enemy health. As for its new value field, we shall set it at 100. For the second set integer value action, we will need to create a new value called enemy health total on our value holder for the soldier. This value is a reference to the overall health of the character and helps define it against its current health. To use this value, we can set the target value action to owner and then set the reference name to enemy health total. Then, for the new value, we can set the target again to owner and then the reference name to enemy health. This will set the value to the correct amount every time the health is reset upon call of this state. Next, we can look at setting up the health bar canvas through using the modify float value action. To do this, we will need to create another value. This value, however, will not be an int, but instead a float. This float value should be called enemy health percentage, and it's used to set the health bar's canvas values. The health bar canvas has its own state machine and automatically updates itself and all that it needs to be as it is set in a local value. We do this first by initializing enemy health percentage inside of the modify float value action. To do this, we set the source value to owner and set its reference name to enemy health. We then want to set the operation to divide. Then, after that, we can set the modification amount to owner and the reference name to enemy health total. Finally, for the target value, set it to owner and then set the reference name to enemy health percentage. In terms of applying this to the health bar canvas, we can go to set float value action and set the target value and set it to owner and turn on the path and reference options. In this path field, we will want to put the value health bar canvas / slider, which will route from the owner to the health bar canvas, a child of the soldier, to its own child, slider, and then in the reference name, set the value to local health percent so that we can access said value on the slider. The value we'd like to set the local health percent to is called enemy health percentage. And to do this, we change the new value to owner and then reference enemy health percentage as the value. For the change state action, we simply need to target the owner and then set the state name to patrol area. Patrol area. This state is designed to be the main patrol state, moving between a set of internalized waypoints until the player is encountered via distance or the AI is shot by the player. So, now that we're looking at the patrol area state, we are going to need a few different cats to get the ball rolling. We need a set bool animation param action, a get list length action, a modify integer value action, a modify bool value action, and a looping action. Finally, we will need a proximity trigger for when the player gets too close to the soldier. For now, let's look at all the individual cats. Individual cats. Going to the set bool param action, we need to set it to false. This will help with resetting the animation of the character model upon re-entry into the state. Later, we will be setting the animation of the attached character model to a different set of animations in our soldier's shooting loop. For now, in the set bool animation param action, set the target value to owner, and after enabling the path option, input as the value enemy model. Then, give as the value for the parameter name aiming. If it isn't already set, uncheck the value field. We need to set this to false. In the getListLength action cat, we need to change the target list to owner and provide waypoints as a list to get the length of. We will use this value to help cycle through different waypoints on the soldier's internalized list. To store this value, we need to create a new value in our soldier's value holder. Navigate over to the value holder and add a new integer value. Call this new value waypoints total. This denotes the total length of the waypoints list on the soldier. Now, specify for the store in value on getListLength action owner, and for the reference name, we input waypoints total. Now the soldier knows the maximum number of waypoints it can traverse. Next, we need to fill in the modify integer value action. We will need another value to complete this cat. In our value holder, we will need a new integer value so that we can correctly loop over the waypoints and pick a new one at each iteration. This new value should be of the type integer, and we should name it waypoint total minus. Now, we can modify this value by going back to modify integer value action and input our values. So, in the source value, we need to select owner and then specify waypoints total for the reference name. After this, for the operation, select subtract, and then for the modification amount, input 1. As to the target value, select owner once again, and then for the reference name, input waypoints total minus. Now, we should have a correct measurement of the number of loops necessary for the soldier's patrol. After this, we go down to the modify bool action. Before going any further, we will need to create another value. We can create this value, this boolean, inside of the soldier's value holder. We can call this value IsShot, let's say. This bool will be helpful later on. We want to set up the logic for when the soldier is shot, and we don't want them to transfer out of their current state. Having the soldier be soft locked into constantly transferring between states would be annoying and not conducive to our gameplay loop. So, inside this cat, we just need to specify for the source value, and the target value too, owner, and then, for each of the reference names, provide IsShot. We would then like to check off the negate value so that the value IsShot is set to false each time. Looping action. Now, we are at the looping action. This cat will define which waypoint inside of the soldier's waypoints list they will navigate to during play. To begin, we would like to set the delay value of the looping action to 3 seconds. As a matter of this tutorial, you can modify this value to your heart's content. This delay will determine how long the AI of your game will take in seconds to move to a new waypoint. With that out of the way, we can add more cats to the looping action itself. First, we would like to use a getGameObjectIndex action and an action list. Inside of that action list, we would like to also add a navigate action and a modify integer value action. To complete the getGameObjectIndex action, we are going to need a few more values on our soldier's value holder. These values begin with an integer value, and we can call this integer value current waypoint index. Next, we need to create a game object value and call it current waypoint. This value will be referenced as the current waypoint to which the soldier shall move during the looping action. On to inputting these values. Inside of the getGameObjectAtIndex action, we want to define for the index field owner and then set for it the reference name of current waypoint index. As for the value list field, we would like to set it to owner and then for the reference name provide waypoints. Then in the store in field, we would specify owner as the target, and then in the reference name, we would like to input current waypoint. This way, we will grab a specific waypoint from the waypoints list and move to it before transferring to another waypoint. A small change we need to make to the action list is to set its runtime field to parallel. You may notice a caution symbol displayed, and this is because of the Navigate Action's internal code. It must always be in a parallel action list if it is to be in one at all. For its target value, we would need to set it to owner, and then set its destination value to owner, and then activate its reference name and input current waypoint as the value. This way, the soldier will move towards its understood internalized waypoint. A last note for the Navigate action is to make use of its animation subsection. Using this section, we can denote our soldier's character model, which has an animate component, and the proper animation which should play whilst it moves from the last traversed waypoint to our new current waypoint. We do this by targeting the animation target as owner, and using the path option, we input enemy model. Finally, as a last edit, we need to set the walk parameter to moving. This way, we can have our soldier play his walk animation while navigating. Let's move on to the modify value action. Inside of this cat, we simply need to specify as the source value owner, and then use the reference name option and input current waypoint index. For the operation, we need to select add and specify a modification amount of 1. We do this to update the current waypoint we would like to move towards next time this loop iterates. So we just then need to specify for the target value of this cat owner and then current waypoint index to update its information. You may ask, however, but wait, if we iterate over and over, we're going to go beyond our waypoint's game object list length. We'll be indexing non-existent values, and you would be correct in saying this. How do we control this? It's simple. We will need to add a triggered action outside of patrol area so that it overlooks the state and the relevant values from afar and prevents an out of size indexing error. Reset waypoint index. Let's go back to the soldier state machine and add a value change trigger. In fact, let's add 2. One for now, another for when we want to update the soldier states when being shot. The first thing we want to do is separate out these triggered action cats by name. We can label the top one as reset waypoint index and the bottom one as health trigger. focus on Reset Waypoint Index. The purpose of this is to check if the value current waypoint index has changed at all, and then, if true, perform some action. So, let's start by going to the Check on Start field, and if not done so already, check it to be true. We want to correct for any time a designer like yourself or a colleague accidentally modifies the current waypoint index out of scope. Now, to properly reference current waypoint index, we need to specify the target field as owner and the reference name of that target as current waypoint index. Following this, in the case of a successful trigger event, we want to modify current waypoint index if it is out of scope. To do this, we will need to add an action list. Then, we will want to add into that action list an integer value condition and a set integer value action. Inside of the integer value condition, we need to set the target value to owner and set the reference name of that target to current waypoint index. Following this, we need to set the comparison type to greater than, and then the comparison value field to owner, and then its own reference name to waypoints total minus. At first glance, this may seem confusing. Why not just use waypoints total as a value to check against if current waypoint index is out of scope? But if you remember the programming paradigm of arrays or lists, you'll remember that in programming languages like C# or C++, that arrays and lists start at the value of 0, and that this causes the last number in a list of, say, 7 objects to be instead the 6th object if going by the object's index position in the array or list. So as to not go over this value and ask for the imagined object beyond the 6th position in the array or list, we need to use waypoints total minus and treat it as our capping value. Now that the integer value condition is set up, all we need to do is deal with this set integer value action. This cat just needs to set current waypoint index back to the first index position within the list. So, after specifying the target field of the cat as owner, we need to use the reference name option and input current waypoint index. After that, we put 0 as a new value, and we have thus changed the indexing value back to 0. As a reminder, let's make sure to put the set integer value action as a child of the integer value condition. If we do not do this, the set integer value action will always reset current waypoint index back to 0 on a value change. Health trigger. Shifting over to looking at the health trigger triggered action, it may not seem relevant to patrol area exactly, but it's actually quite useful for controlling when we want to otherwise exit out of patrol area or any other relevant state entirely and enter into our different combat states. Setting up is relatively simple and not dissimilar to how we did reset waypoint index. To begin, let's make sure that check on start is checked on, and then set the target value to owner, and then set the reference name to enemy health. This way, we are looking to check at every instance of when the enemy health value changes to perform some action. Now, what to perform? Well, we're going to need an action list. We want to set the action list to serial, if it's not already done so. And then, inside of it, we need to add a modified float value action, a set float value action, a play sound action, and an integer value condition. We want to use the modify float action to modify the values of the health bar canvas before actually visually updating that information. To do this, we need to reference our health values. For the source value, we need to target owner, and then, in the reference name, input enemy health. Next, for the operation, select divide. Then, for the modification amount, target owner and input enemy health total for the reference name. Then, to store this modification, we need to specify for the target value owner and the reference name of that, the value enemy health percentage. Now, we need to update the visuals of the enemy soldier's health bar with this value. Navigating down to the set float value action, we will want to set the target as owner and add the path and reference options. Inside of the path option, enter in the value health bar canvas / slider. Then we can go to the reference name and input local health percent. For the new value, we will need to target owner once again, and then provide as a reference name enemy health percentage, so that in the end, we are setting local health percent to enemy health percentages value. With that out of the way, we can set up the play sound action. This sound effect is played so that every time we shoot the soldier, there will be an audible reaction to the user input. We don't have an animation to play at the moment, but if you happen to have one set up on your own NPC, this wouldn't be a bad spot to put it. Anyway, we want to set the target to owner, and for the clip, we want to navigate over to the project folder and find Hit Hurt 2. This is the sound effect we want to play. Finally, all we need to do is check on Keep Playing After Stop. This way, the sound effect won't cut short when the soldier is hit. Now, we can move on to the integer value condition. This conditional action helps control for the contingent states of the soldier, death and charge. Death is just that, where we want to disable this NPC and perform all the actions related to their death. For charge, think of it like a berserking state and is a last-ditch effort on behalf of the soldier to kill the player. To set up sending the soldier to its death state, we need to modify the integer value condition. First, we need to set the target value to owner and then use for its reference name enemy health. We want to then set the comparison type to less than and set the comparison value to 1. Now, we want to account for when this evaluates to true and false. Add two action lists. For the first action list, we want to add one cat, a change state action. We want to set its state change field to death. For the second action list, we need to first set it to be an else action by clicking the small icon. Inside of this action list, we need to add another integer value condition. Like previously, we need to specify for the target value owner, and then for the reference name, we input enemy health. For the comparison type, select less than, and for the comparison value, let's set the value to, say, 15. So, when enemy health falls below that value, we transition to charge. But should this happen every time? I say no. Let's instead make it a probability to add some extra variance to our soldier. So, under this conditional action, let's add two action lists. Set the second one to be an else action. In the first action list, we need to add a chance condition. Let's set it to 50%. Then, under it, let's add a change state action. And set it to owner and select charge as its state's name. Now, for the second action list. Let's add a bool value condition. Check on its negate field. Then, for the target value, set it to owner, and then enter for the reference name IsShot. This would be a little confusing. How is this bool relevant? IsShot controls for preventing a soft lock of the soldier during combat. The idea here is that since this trigger will fire every time enemy health is changed, we need to prevent the transition to ask for cover. In the case that this is the first time being shot, we need to transition to the ask for cover state. So, we do that with a change state action underneath the IsShot bool value condition. Then finally, we set the state name to ask for cover and target the owner. This concludes the health trigger. Detection radius. Let's go back to patrol area and finish up. We look back at the triggered action from before and want to use this action as a detection radius for the soldier through analyzing proximity. To set this up properly, we'll need to check on start if it is on. Then we need to select the target field and pick owner. Next, for the radius, we want to set it to 15. You can set this value to however far or close you desire. But for me, here in this more urban environment, with a certain assumption of noise cancellation from other sounds, this fits my level of believability. Sure, it's not totally accurate, but to recreate the complexity of our own understanding, our own spatial recognition, is one of the terrible challenges of artificial intelligence. Thankfully, we're fine with making fairly limited AI. For the collide target, you want to set that to target player. A brief note, this will target anything tagged as player. So, you'll have to use a tagged reference type to properly sort for when using multiplayer characters, etc. Now that we have set up this triggered action, we can move on to what we want to do. So, let's add an action list. This action list will handle all of our desired actions one after the other. So let's set the run type to serial. Then, inside of it, let's add a bool value condition and an action list. This bool value condition will need a new variable, one which can totally ensure that we cannot return to our combat loop upon the enemy's health lowering beyond the killing threshold. This new variable will be a boolean value called isDead, and we can create this boolean on the value holder of the soldier itself. Now that we have this value, we can go back to the bool value condition and in the target value, target owner. And then, for the reference name, submit isDead as the value. Now, let's not forget though, we only want to reach what follows if isDead is not true. So, we need to check on the negate field of the bool value condition. With this out of the way, we can add another action list. This new action list helps separate out sets of actions that the soldier needs to perform. Other than transition to another state, it needs to play an audio cue to affirm the idea that the player has been detected. We can do this in a varied way because we are using a random number to determine the sound effect which should play to indicate detection. To do this, we need a new integer. Inside of the value holder, let's add an integer called detection sound index. Not quite creative, but gets the point across. And we can use this to accomplish what we need. So, back in the action list, we can add a set random int action, and for the target value, select owner, and provide for the reference name detection sound index. Now, given that I have 3 sound effects, detected, detected 2, and detected 3, We can choose between these by setting the min value to 0 and the max value to 3, which is exclusive, not inclusive like min value. We can access each value in a cascading set of integer value conditions. So, we need to make a sibling action list to set random into action and put inside of it an integer value condition. To set up the integer value condition, we need to set the target value to owner and use the reference name detection sound index. The comparison we want to make here is for the first sound detected, which we can find underneath the audio folder in our project window. So, to do this, we set the comparison type to equal, and then set the comparison value to 0. When this evaluates to true, we want to play the sound associated with it. So let's add a play sound action. We can then set the target to owner, and for the clip, we can input the sound effect detected from our project window. Lastly, we just need to keep playing after stop checked on. So let's make sure that's the case. Okay, so now that we have the first sound, we can do the second and third sounds. Let's duplicate the conditional action of the integer value condition and make the duplicate a child of itself. That way, the duplicate is contingent based upon the result of the first. Now, what we want to do with this duplicate integer value condition is to first set it to be an else action. This way, it is only checked if the parent integer value condition is evaluated to false. The only two things we need to change in this conditional action duplicate is to set the comparison value to 1 and then set the clip of the play sound action to detected 2 from our project window. Finally, we can duplicate this conditional action set again and do the same thing we did as before, where we childed the cats to the current conditional action of the integer value condition. Doing this, all we have left to tie up is to change the comparison value to 2 and change the clip to be played to detected 3. Now, we should have a cascading set of integer value conditions which will play a different detection sound based on the end result of the set random int action. Some of the last elements we need to deal with in terms of the detection radius is to add a change state action to the action list of the isDead bool value condition. By doing this, we can transition to the ask for cover state where we enter our combat loop. So, after adding the change state action, set it to change to the ask for cover state. With this out of the way, let's transfer over to the ask for cover state itself. This concludes this part of the tutorial. I'm Kevin Ward.
And I'm Josh Mulligan.
And see you next time.